So we have to know how to graph a function to determine if it is a function. Right now, what you have is an equation, and we want to know if this is an equation or not. Naturally, we can use vertical line test to determine if this is an equation, excuse me, if this equation is a function or not. So press y equals, and you should see that screen that's over there, and type the right-hand side, which is 1 over x, and in the top right corner, you should see graph, and simply hit graph. And we see a function of that sort. I'll go ahead and draw that over here. Now, if I drew a vertical line through this particular curve, no matter where I draw that vertical line, may it be here, or there, or there, in the entire domain of the function, you can see that the vertical line touches the curve exactly at one point. So the first one that we have is a function. So this relation that we have, which is y equals 1 over x, passes vertical line test. Since it passes vertical line test, the expression y equals 1 over x is a function. The next one, we have 1 over x minus 3. So again, we go back up there to y equals, and instead of 1 over x, we have 1 over x minus 3. So 1 divided by x minus 3. So it pretty much is the same curve, but it sort of is shifted to the right by 3 units. So in this case, so the shape is the same. So if I draw a vertical line through it, no matter where I draw that vertical line, it is going to touch the function exactly at one point. So we would end up having a function. So y equals 1 over x minus 3 is also a function. Oops. So the next one we have is x is equal to y squared. You should notice that the x and the y, they are flipped. So if you pick a value of x, then it has to satisfy y squared. So this one is a bit tricky. So what I'm going to do is I am going to pick values for y this time. So let's pick an easy value. Let's start with 0. If I plug in 0 for y squared, so if y is 0, x is 0. If y is 1, x is 1. If y is 2, x is 4, because I'm plugging in 2 for y squared, 2 for y in y squared. Now I want to pick some negative numbers to see what happens. If I pick -1, I would end up getting 1, because -1 squared is 1. And if I plug in -2, I would get x is equal to -2 squared, which would give me +4. So now when x is 0, y is 0. So what we have is that point right there. When x is 1, y is 1. When x is 2, when y is 2, x is 4. Likewise, when y is -1, x is 1. When y is -2, x is 4. So the curve would be of that sort. This is just an approximate curve. And I could draw a vertical line through this. And that vertical line is only going to touch exactly at 1 point in this case. So that is also a function. The next problem, x is equal to the 2 vertical lines, simply would mean an absolute value. We're trying to find the absolute value of y. When y is -2, x would be +2, because the absolute value of -2 is +2. When y is -1, we have absolute value of -1, which would give us +1. When it is 0, you would have 0, and 1, absolute value of 1 is 1. So And you go ahead and you place the points 1, 2, -1, -2. You have 1, 2, -1. Clearly, we can't have a negative value. So when it's 0, you get 0. When it's 1, it's 1. When it's 2, you get 2. Same thing over here on the other side. 1 and, excuse me, -2, and you get 2. And you would say, okay, I draw a vertical line here and see if the vertical line test works. Now, it is going to work, and you are going to conclude that this is a function like you did in the previous problem. So, as said, you have to be cautious in this problem, or the last two problems, for a reason. And I am going to change the conclusion because I wanted to show you this, indicating that most people would conclude that the relation is in fact a function. But if you observe closely, there is a subtle change in the last two problems compared to the first two problems. So I am going to put a note here that whatever conclusion that we obtained, or that I intentionally did, is incorrect. Why is that? Now, even though the vertical line test would pass, we have the x and y switched. So the graph is not going to look like what we have here or there. So how do we graph this? So we are picking values of y. So this part is 0, that's not a problem. When y is 0, x is also 0. When y is 1, x is 1, so I'm right here. When y is 2, x is 4, so I'm going to move over and plot that over there. When y is -1, x is 1, because we switched the order. And when y is -2, x is 4, so we have that. So the curve actually is going to look like this. Not, oops. Not like the one we had previously. So if the x and y's are switched, instead of drawing a vertical line test, you have to draw a horizontal line to see if it's going to touch 2 points or not. So if we have the correct graph, when I draw a vertical line, it definitely touches at 2 points. So x equals y squared is not a function in a traditional sense. So if I switch the axes, the chances are it is not going to be a function. The same argument will apply for the next equation also. So when the value of y is 0, x is 0. When the value of y is 1, x is 1. So it's right over here. When the value of y is 2, x is 2. And likewise, if you plug in -1, when it is -1, we get 1. -2, we get +2 for the x value. So if you draw a line, it has to look like that. And would it pass the vertical line test? It is not going to. So if I draw a vertical line, it's just not going to pass it because it touches 2 different points. So x equals absolute value of y is not a function either. A key remark. So if we switch x and y, then whatever expression that we have, whatever relation that we have, is not a function in the conventional xy plane sense. So another way to look at it is, well, if you incorrectly graphed it, as we did earlier, you shouldn't be drawing a vertical line. We switched the x and y, we have to draw a horizontal line. But we don't like to do that because there is a test called a horizontal line test, and we don't want people to get confused. So you have to realize that the x and y are switched. So you have to realize that you have to be careful when you're graphing it. And if you remember this remark, anytime you switch x and y and have it as a relation, the relation is not going to be a function. It is more than likely to be not a function. So here we have different functions, and what we have to do is evaluate the value of the function at a specific value of x. If you look at the given expression, that is simply a function of x. So I could put in any value for x and I can evaluate the value of the function. So which is why sometimes the x value is called the input and y value is called the output. For instance, if x is given as an input to f, you end up getting y. So what do we mean by that? In the first problem, the value of x is 0. So if I plug in 0 for x, I would have 1/2 times 0. I'm replacing x by 0. I would end up getting 0. So when x is 0, y is 0. So input value, x is 0. Output value, y is 0. When we plug in 2, I'm replacing on the right-hand side the x by 2. So we have 1/2 times 2. The 2's would go away. We get 1. So the input value is 2. The output value for y is 1. And lastly, we have f of -2, which would simply mean we are plugging in the value -2 for x. which is right over there, minus 2 over 2, which would give us minus 1. So the input value is minus 2, the output value is minus 1. So moving on to the next problem, we have g of x is equal to 2x squared plus 4. Now, I always tell my students, anytime you see something like this in the power, put parentheses around the variable. What do I mean by that? Even before you start the problem, you rewrite it as 2x squared plus 4. This way, you don't make any mistakes. So the first time we have an input of negative 11. Now, in the previous problem, things were quite easy, it was straightforward. But here, we have some big numbers and you have a square and so forth. So you can make use of the calculator to make the process easier. So how do we go about doing this in the calculator? Of course, you can do this manually, but I'm trying to make this process easier. So hit y equals 2x squared plus 4. Then press second mode to exit. Now press second window. You should see the table set up. Leave everything as is and switch over to that line where the cursor is blinking. That is the independent variable. I'm going to switch that over to ask and leave the dependent variable as is. So once we have this table set up, what we're going to do is exit, press the blue button, second mode, it will exit. Now press second graph. So it is going to wait for us to give us a value for x. So if I plug in negative 11, the answer is 246. So when x is negative 11, y is 246. The next value of x is negative 1, so I'm going to plug in negative 1. The y value, or the output value for g, is positive 6. In the last case, it is 1/2. So if I plug in 1/2, I end up getting 4.5. And that is the same as 9/2. So we have h of x is equal to 7. So h of x does not depend on x. That is, there is no x term on the right-hand side. So no matter what value of x you plug in, h is not going to change. In other words, the output remains unchanged for any input. So when you plug in 7, you'd simply get 7. When you 2, you would simply get 7. When you plug in -3/4, you would simply get 7. Now, could the calculator give us the same thing? You can go back to y and press 7. Anytime you reset or turn off the calculator, the table setting might change. So let's verify if it's still there. So second window, it obviously changed. So switch it over to ask. Second mode to exit. Second graph to get the table. So I'm going to plug in the value 7, y is 7. I'd plug in 542, y is 7. -3/4, y is 7. Plug in 100, y would be 7. Plug in -1000, y would still be 7 because the function does not depend on x.